There we go. Okay, so this is the applications of quadratic equation. It's step by step on what we're going to do. Okay, so all the following problems are formulas that model the path of a projectile up into the air and then falling back down under the force of gravity. So we've used this formula, and they'll usually will always tell us where h is the highest part of the arc, so your parabola, and then t is the time that it takes to get there, initial velocity, and c is the starting height. We'll use our vertex formula, t equals negative b over 2a, or the opposite of b, to find the number of seconds it takes. We've been using this already, but now we're going to apply it. So we're going to take number of seconds it's going to take to reach the max height. Then we substitute it back into the quadratic to solve at what height it's going to be. So we're going to do some of these together. And then it says don't forget to write with a sentence. We'll talk about that. All right. So at this point, if you don't have this printed off, that's fine. Just watch what we're doing, and then we can write it down. So we have diving Danny starts on a platform 50 feet above the pool. Assume he's starting upward velocity is 8 feet per second. How many seconds until he reaches maximum height, and what will the height be? Okay, so with word problems like this, sometimes I have to read it 2 or 3 times. So diving Danny starts on a platform 50 feet above the pool. So sometimes I even like to draw. Do not criticize my beautiful drawing. Just see. Okay, so we have like a platform. Here's diving Danny. He's smiling. He has arms. Don't forget the arms. All right, that's a really long. Okay, so he walked up. It's like a diving board. It's kind of like a little thicker here. Okay, so it's a diving board. And then there's water. Here's the pool. He's starting 50 feet above the pool. So this is 50 feet. Draw out pictures. If you have to draw it out, draw it out. All right. So assume he's upward velocity of 8. So we're going to start with this equation. All right. So we're going to use this equation, and we're going to plug in the information that we know. We don't know the h yet. Negative 16. Now we don't know the time yet, because we got to figure out the time when we have our velocity. So we
can't see your screen.
Oh! That's important to know. Okay, what do you guys see? Anything? Just me? Did you guys... And I didn't even see it. Yeah, thank you for speaking up. Your screen isn't sharing. Your screen is sharing. I can't see. Are we supposed to see? Yeah. Thank you for unmuting. You're probably like, okay, she's not looking at her chat. Yeah. Okay, so let's back up. And my beautiful diving Danny. I wondered why nobody either laughed or commented on it. All right, so here we go. So diving Danny starts at a platform 50 feet above the pool. Assume he's starting upward, velocity. Because so some of you just are now seeing this question for the first time. Okay, so diving Danny. Here's the board. He's 50 feet above, so there's 50 feet above the pool. Okay, so now we're going to use this equation, negative squared. Now here's you're going to replace the 8 for the v. Then he starts, now your c, that is the starting height. He's starting 50 feet above the pool. Okay, now we have to figure out the time in which it reached where he... the time he reached the max height. Because remember, it's an upward velocity. If you've been on a diving board, sometimes people just stand there and then dive off, so that's their max. Sometimes they springboard it, they jump, and they dive up. So he's probably going to be diving up, so he has a max height somewhere up here. Okay, so we're going to use the vertex formula. Negative b, the opposite of b over 2a. So I'm going to do that over here. So t equals the opposite of 8 over 2 times negative 16. Negative 8 over negative 32. Which that is 1/4. You can do a fraction or a decimal. I'd almost do a fraction. Sometimes I do fractions, sometimes I do decimal. The only thing is because I know I'm wearing, but I mean, you can do 1/4 or point, no, oh yeah, 0.25. So you can do either one. Now, this is your time. So the time, actually, since we're talking about time, we're talking about 1/4 of a second. So the time it took for him to reach his max height was 1/4 of a second. Now we got to figure out the max height. You're going to put that 2500 or 1/4 in for t. So a -16, if you do 2500 squared plus 8 times 2500 plus 50. So all I'm doing is plugging it in first. Now I'm computing. I need to square the 2500 first. Now 25 times 25 is 625, so 2500 squared. A 1/4 of 8 is 2. Okay, and then multiply these. Oh, that's just -1. Oh. Yeah, that makes sense. Okay, plus 2 plus 50. So we have a -1 plus 50. -1 plus 2 is 1, plus 50 is 51. Okay, so let's talk about what that means. This means in 2500ths of a second, Danny reached the max height of 51 feet. So he started at 50, so he just went up 1 more foot. You're like, that's not very far. But he reached in 2500ths of a second, Danny will be at 51 feet. Danny will be at or if you put it in past tense, if it took him 2500ths of a second to reach the max height of 51, or he was at 51 feet after 2500ths of a second, that's fine. As long as you have, it took him 2500ths of a second, 1/4 of a second, to reach the max height of 51. So when he jumped, he did a little springboard, jumped up, and then dove in. So up here, 2500ths of a second, he got to his max height of 51. Okay. All right. Does anybody have any relatives in the military? Okay, this is the word that has always thrown me. It's pronounced colonel, correct? Why is it pronounced colonel when we don't have an R in it? That has always thrown me. So anybody who's in the military, ask them. I'm like, why? But it's pronounced colonel. Colonel, but it, unless I'm pronouncing it wrong. But no, it's always pronounced colonel. Okay, Colonel Cody is at the cliff top fort and fires a cannonball up into the sky, hoping that it would arc and hit a pirate ship in the cove. If the cannonball is fired at an initial velocity, from a 100-foot cliff, it'll reach the max height, and what would the height be? All right, so we have top at a cliff of a cliff top fort and fires a cannonball. Okay, so he's up on a cliff. Here's our colonel. Here's our cannonball, or our, oh my God, what's it called? Our cannonball thrower. Cannon, it's called a cannon. Oh, I don't know why I did that. So here's our cannon. All right, so he's going to shoot. Here's our pirate ship. A skull and... I'll just do that. It looks like a golf course. Anyway. All right, so he's going to shoot this cannonball up. He opens arcs and then lands on the ship. Looks like a cow. Okay, now how high? What do we need to know? Okay, 100-foot cliff. So this is 100 feet. Cannonball is fired at initial velocity of 224 feet. Okay, so this is where we're going to plug t squared, that's the same, plus 224t plus 100. So that's our initial velocity. This is our starting height. -16, that's our gravity. That's the pull of gravity. And I had to ask the chemistry teachers and high school math teachers years ago when I first taught this. I'm like, where's the -16 coming from? And they said that that was the, I don't know, the formula for the pull of gravity. I guess. Okay, now let's find the time it takes for it to reach its max height. We need to know how long it's going to reach that max height. So T equals to B, 224 over 2 times A Okay, does anyone want to tell us what they have? 224. Oh, wait, I wrote that wrong. I better recalculate. 224 divided by 32. Now they're both negative. And you guys, if they're both negative, I don't even waste the time putting in a negative sign. Okay. Then, so that time is, did you get 7 seconds? Okay, so it's taken it 7, so that ball, it takes it 7 seconds, that cannonball, to reach the max height. Now we're going to put 7 in for the time to figure out the height. -16 t squared plus 224 times t plus 100. -16 times 49. Even though I'm using my calculator to compute, I am writing everything down in case there's an error. Then I don't have to sit and go, I don't know what I did. Now that's a negative. -784 plus 1568 plus the 100 feet, because we know we're already 100 feet, so we need to know the max height. Okay, so the max height, I'm coming with 884 feet. So it was at 100 feet. And then in 7 seconds, the max height would be 884. Now, somebody would ask me every year, they're like, well, if we know it's traveling at 224 feet per second and we know it goes 7 seconds, why don't we just multiply these two? They're like, why don't we just take the time times our feet per second and call it good? Notice that's what we do here, but what's happening here is the force of gravity. Because as it's going up, you guys take physics, if you can ever take physics in high school, so interesting. So interesting. If you like to see how things work, and it's so interesting. Anyway, so the sentence. In 7 seconds, you can put in 7 seconds, the cannonball reached 884 feet. So in seconds, the cannonball reached 888. Wait, 884? Yeah, 884. Okay, I'm going to stop that.